These are the section 6.3 and 6.4 notes, page 5. So one more example here, the compound interest formula, just as a reminder. So we want a function for the amount A of t after t years, and we are just going to plug in the information from above. We have $1,000 invested at 3.5%, compounded quarterly for t years. So you can plug that in. Actually, this would be a great place to pause the recording. Plug in t equals 0, 4, and 8, and make sure you come up with the following answers. A of 0 is $1,000, which makes sense. That is the amount that you have at time t equals 0. That is our original investment. A of 4 is $1,035.46. And A of 8, after 8 years, we have $1,072.18. All we're doing for C is rewriting this equation to show what it would look like if it were compounded monthly. And we're going to replace our quarterly compounding periods, that 4, with the 12 for monthly. Okay. We are going to start talking about graphing logarithmic functions, identifying the important parts. We're going to start, because we know the logarithm is the inverse of the exponential, we're going to start by graphing this exponential function. So here's our exponential. F of x equals 10 to the x. Goes through 0, 1, goes through 1, 10. Nice and steep. And then down towards the x-axis over here. Super straight. For our exponential, we know that the domain is the set of all real numbers. The range is the positive, so we're going from 0 to infinity. We have no x-intercept. Our y-intercept is 0, 1. And our asymptote is y equals 0, which happens to be the x-axis. We want the inverse of that function. So we're going to do what we need to do to find the inverse. We are going to go ahead and swap the x and the y. And we are going to rewrite this as a logarithm to solve for y. So our base is 10. I get log base 10 of x equals y. Again, that is also the common log. So our inverse function here can be written as log base 10 of x, or just log x. Okay. Easiest way to graph this is to just swap our x and y values. So I know that this point 0, 1 is on my original function, and this point 1, 10 is on my original function. So on my inverse, I've got 1, 0, and I've got 10, 1. And so my logarithm looks like this, the inverse of that exponential. I know that the range of my original function is going to be the domain of my inverse function. So my domain here is 0 to infinity. I know that the domain of my original function is going to be the range of my inverse function. So my range is infinity to infinity. Okay. Here I have an x-intercept. We have no y-intercept. And our asymptote, again, x swaps out for y. So it's the line x equals 0, which is our y-axis.